Good morning to all of you. Welcome you guys. Welcome you all. How you are doing? Very good morning to all of you. Yes, I think we are live. First of all, do comment करके बोलिए ना is audio video is clear to everybody. Do comment करके बोलिए. Yeah, so here a great news to the aspirants who are preparing for 2027, 2028 ka. So this Unacademy subscription that is just 9,499 rupees only. And 12 months plus additionally 1 month का extension भी आपको मिलेगा. So this is a never before opportunity. So utilize this opportunity before going to expire. And the 9 months plus 1 month free subscription that is just 8,499 rupees only. And the offer ends tonight. So tomorrow is the last day to avail these opportunities and use the code of BB Reddy and to avail these opportunities and have a great learning experience from the top educators. Right. So never miss these opportunities. Utilize this opportunity before going to expire. So we started a new batches. CIL का batches हमने शुरू किया. Digital and English is running. You can find the top educators team आपको एक साथ मिलेगा. And we started the new batches from 28th May से शुरू हुआ. That is EDC starting. And so Mahaveer batch and this Unacademy. So GATE 2026 का rankers program. You can have a look at. Right, ESC, Unacademy. So here ESC 2025 का rankers. Right, next Unacademy Una. So it has a 3 modes of operations. That is, one is voice mode, quiz mode, and smart summaries. So according to the requirement, you can utilize this Una so that it will helpful for you. And if you ask to summarize the things now data, so it will summarize the complete information. It will summarize. Okay. Yes. Utilize these opportunities. Right. Now the test series which is available. And so we do offer the 2 subscription and plus subscription. The other one is iconic subscription. Plus में आपको क्या चीज मिलेगा? The top educators classes मिलेगा, live doubts होगा, evaluated test series भी मिलेगा आपको, and इसके साथ you will get the structured courses and PDF and live test होगा, unlimited access. Iconic में additionally personal coach भी मिलेगा and physical notes भी मिलेगा. Right. So according to your time slot, you can book your time slot and you can connect with your mentor. So you can start the serious preparation with an academy to achieve your dream goals. Right. So chalo, let's continue our discussions. last class, how many problems we have completed? You can have a look at. Around 82 problems we have finished and will continue the remaining problems now. Yes. Next one. Take the next problem. 82 problems we did now. Let's take the next problem. A galvanometer of 2 ohm resistance is connected in the given circuit. The ratio of the charge stored in C1 and C2 is. Yes. So this is now the supply, which is what type of supply you can see now, DC supply for DC case, and how the capacitors will behave. So tell me now, the capacitor will behave like a open circuit for DC. Now if I redraw the circuit now here, how it could be now, tell me. So this is the bridge circuit and capacitor which is open circuit now, and galvanometer we have some resistance. That resistance is given as a 2 ohms given, and so the circuit will become as like this. Here we have the resistance is given, and this is 4. Volts. Now here the capacitor here will becomes open circuit, and this capacitor is also open circuit. Capacitor is also open circuit like this. Right, now you can tell me now here, and this is 6, and the given galvanometer resistance is given as a 2. Yes, they given this as a 2 volts. Yeah, you tell me now here. So this current will pass in this path now. How much the resistance you can see now here, 10 plus 2, 12. So equivalent resistance, how much is value, 12 ohms. Equivalent resistance is 12. Yeah, you can see now here, this thing. If I call this voltage is V1, and this one, this voltage is V2. Now, you can see now how much this current is now here. That is 6 by 12, which is equal to 1 by 2 amperes. Yeah, you can tell me now here. So this current is 1 by 2 amperes. This current is 1 by 2. This current is 1 by 2 amperes will go. Now we can write the KVL in this loop now to get the V1 value. So you can tell me now how much is V1 value? 4 into 1 by 2. So this is 1 by 2 into 4 plus what will be now 1 by 2 into 2. So how much is V1 value? 2 plus 1, which is equal to 3 volts. Next, by writing the KVL in this loop, we will get the V2 value now. So we can get V2 value is what will be now 1 by 2 into 2 plus 1 by 2 into 6. So we will get the V2 value is 1 plus 3, that is 4 volts. Now from this, we can get the charge ratios. Now here we need to find the Q1 by Q2. Q1 by Q2. Q1 is what we can say now C1 V1 by C2 V2. So C1, how much the C1 is 4. 4 into 3 by, so C2 value 6 into 4. So this will becomes 1 by 2. So this option D. Got it, all of you? Next, in an electrical circuit drawn below, the amount of charge stored in the capacitor is. How much the charge the capacitor will store? So you can see now capacitor will be a open circuit, So how much the equivalent resistance now? Tell me now. Which will be equal to 4 plus 6, 10. Then how much is current now? Tell me now. 1 ampere. So this current which is 1 ampere. Now this current is also 1 ampere. So this is also 1 ampere. So we can find this voltage now. How much is voltage? 6 volts. This voltage is 6 volts. Right. So this voltage 6 volts and the voltage across capacitor is also 6 volts only, isn't it? Now we need to find the charge now here. Q is equal to C into V. That is Q is equal to C value. How much now? 10 into V value. How much now here? 6. So that means how much we can say now here? Q is equal to 60 microcoulombs. Next, the charge accumulated on the capacitor connected in the following circuit is the charge accumulated on the capacitor. Now we need to find the charge. Now let us find the voltage across the point A and point B. So this is VA and this is VB. Voltage will find VA and VB and we'll find the charge now here. So you can tell me now VA and VB. So VA means now capacitor is open circuit and the VA means we can say this is the voltage across this resistor is VA na? This is VA and voltage across R4 is VB. We can apply VDR. That means now VAB, voltage across capacitor, which is equal to VA minus VB. So how much is VA value? That is 2 by 3 into 10 minus VB value 4 by 10 into 10. So how much is value? Tell me now here. 20 by 3 minus 4. So that means we'll come it as 20 minus 12 by 3, which will come to be how much now? 8 volts. That is VAB. Now from this we can get this charge now here. 8 by 3. So 8 by 3. So which is equal to Q is equal to C into VAB now. How much the C value given now? 150. 150 into VAB value, how much now? 8 by 3. So 3 5s. So here, so that means 8 5s 40. So it will become 40 na 400. 400 microcoulombs. Okay. Next. A network of 4 resistances is connected to 9 volts battery as shown in figure. The magnitude of voltage difference between points A and B is voltage difference between the points A and B. That means if I call this voltage VA and this voltage is VB. So this VA means voltage across this element now. This is 4 ohm resistor. And this VB means voltage across a 2 ohm resistor. So you tell me now how much is VA value? Yes, so we need to find VAB. VAB means what? Tell me now. VA minus VB. So that means VAB and which is equal to VA value, that is 4 by 6 into 9 minus 2 by 6 into 9. So will come to be a what? Tell me now here. 9 So here 9 into 2 we can common, 18 common now. This is 18 by 6 we have taken common. Then it is 2 minus 1 which is equal to 1. So this is 18 means 3 is now here. So this is how much is voltage value, we got it as a 3 volts. This is the voltage difference. That only they are asking na? VAB, the difference between these 2 points. Next one. In the circuit, the energy stored in the capacitor is nothing but half CV squared. We need to find the potential difference. We need to find. If I call this point is A and this point is B. So then this voltage is VA and this voltage is VB. Now you can see now here. Now this voltage means voltage VA means voltage across this 9 ohms na, and VB means voltage across 2 ohms. And let's find this thing VA and VBs. What will get this VA value? So that is given as 9 by 12. 9 by 12. So let's directly will do here. Why this thing here? VAB we can calculate now directly. VAB which is equal to VA minus VB. And so VA, how much this value, tell me now here. 9 by 12 into 12 minus, that is 2 by 12, 2 by 6 only. 2 by 6, 2 by 6 into 12. So how much this value, tell me now. So 12 cancel, so this value is 9 minus. So here this is 9 twos, which will be a 4. Now that is given as 5. This is the 5 volts VAB. From this we can get this energy now. So the energy stored by the capacitor, which is equal to half CV square. So that is 1 by 2. C value how much now? 6 into V value, what tell me now? 5. 5 square. So then this value will become 2 3s now. So this value, what I can say now here, 3 into 25. So which will be equal to 75. I think micro, na, capacitance given micro, na, so it is microjoules. Next, in the circuit diagram shown in the given figure, the current flowing through the resistance 3 ohms is. Okay, we need to get the current in this resistor. Yeah, let's find the equivalent resistance now first. These two parallel, which will be at 2 ohms now, to 4.5. So that means R equivalent, which is equal to 2 plus 4.5 plus 0.5 plus 1. How much is value? 5. 5 plus 3, 8. 8 ohms. Then from this we can get the current in the circuit now here. Current delivered. So here this 8 positive connected, which is opposing now. So that means current delivered, which will be equal to 4. That is 4 by 8, which will be equal to 1 by 2. 1 by 2 amperes. So that means up to here 1 by 2 amperes of current will go. Here onwards current will divide now. If I call that is I. So 2 resistors, we can apply 2 resistors CDR now. And opposite resistor should be taken now. 6 by 6 plus 3 into 1 by 2. So that is I is equal to 6 by 9 into 1 by 2. 2 threes. Okay. 3 threes na. So this value how much now? 1 by 3 amperes. Next. In the given figure, the resistance of the coil of galvanometer is 2 ohms. The EMF of the cell is 4 volts. The ratio of potential difference across C1 and C2. Yeah, this kind of the similar problem we have seen already. So galvanometer resistance is given. So if we redraw the circuit now here, how we have the circuit, you tell me now here. Galvanometer resistance is given. So in this path there is a flow will happen. Flow of current. Mhm. Now this is 4 volts. And here we have the resistance. How much is one? 6. Galvanometer resistance is given as a 2. And then this is 8 volts given. Right. Now here we have the capacitance. Capacitor will behave like an open circuit. See, the supply is a DC supply. So if I call, this is C1, this voltage we are calling it as V1. This voltage I am calling it as V2. Yeah, you can tell me now here V1, V2 values. How much will come? So we can find the resistance of the circuit now here first of all. How much the resistance you tell me now? I value. So which will be, yeah, first of all we can find the R equivalent. How much now here? 8, 8, 16. That is 16 ohms. I value which is equal to 4 by 16, which will be equal to 1 by 4 amperes. Now from this, so this much of current is flowing here now, 1 by 4 amperes of current is flowing. This is 1 by 4 and this is 1 by 4. Now we can write the KVL in this loop now to get the V1 and KVL in this loop to get the V2. So you can tell me now KVLs now here, V1 value. So how much will come here? 1 by 4 into 6 plus 1 by 4 into 2. So how much is value? 8. 8 by 4 which is equal to 2. Next V2 value how much now? That is 1 by 4 into 2 plus 1 by 4 into 8. So this V2 value how much now? 10 by 4 means what we can say now? 5 by 2. They ask him to find the ratio V1 by V2 only na? V1 by V2 which is equal to 2 by, that is what will be now 5 by 2. So we'll come it as 4 by 5. So this is option. Next one. Figure shows a part of an electric circuit. The potentials at points A, B, C are given 30, 12, 2. The current through 20 ohm resistor is. Okay, at this point the voltage is given now. Voltage given here, which is equal to 30 volts. At the point B, voltage is given as a 12. At the point C, voltage is given as a 2. Yes, now if I call this voltage is something V, we can write the nodal equations now. Tell me now what I can say now. V minus 30. V minus 30 by 10 plus V minus 12 by 20 plus V minus 2 by 30, which is equal to 0. Denominator 0 I cancelled. So we can write now V common here. So we'll come it as 1 plus 1 by 2 plus 1 by 3 now, and which is equal to, so this is 3 plus 12 by 2 means we'll come it as 6 plus 2 by 3. So LCM here. So we'll get this LCM which is equal to 60 the LCM. And so we'll come it as what I'll know 6 plus. So this is 3 plus 2. And which is equal to LCM here. 3 is LCM. Now which is equal to 9 plus this is 18 plus 2. So cancellations. Now this is 3 2s. So how much will come? Now this is V into what you tell me now here 11 by 2, and which is equal to what will be 29 now 29. So V value will come to be a 2 into 29 by 11. Oh, we need to get the current through where now tell me now to this resistor 20. So we can write as 2 into 29 means this is 18 and 58 na by 11. So we need this current is I if I call, which will be equal to what we can say now V minus 12 by 20, which will be equal to 58 by 11 minus 12 by 20. So we can cancel, check now here, 58 minus 11 into 12 by 11 into 20. Yeah, how much is value? 58 minus 11 into 12 by 11 into 20. So 0.3 something we are getting. The option is not matching. चेक दिस थिंग हियर, कोई गलत किया क्या मैम हमने? चेक करके बोलिए, अगर एक बार चेक करो, इज द वैल्यूज में एनी मिस्टेक किया हमने? They given that A means 30, B means 12, C means 2. Okay. Now you can tell me now here V. So we can write now V minus 30 by 10 plus V minus 12 by 20 plus V minus 2 by 30 equal to 0. Okay, so now the 0 is removed. So we'll come it as V common. This is 1 plus 1 by 2 plus 1 by 3. Yes, which will be equal to 30 plus 6. Okay, plus V2 by 3. I think here earlier we have taken 3 only, I think so. That might be the mistake, I think so. We have taken LCM. So 6 is the LCM, 6 plus 3 plus 3 plus 2. And here 3 is LCM now here. So this is 90 plus, this is 18 plus 2. 3 2's. Now we can say this as 11 by 2, which will be equal to 20, 110. 110. So we can say this as 11 tenths now. So that is V value will become as 20. Earlier we have taken, I think so, this is a mistake now. We have taken 3 only. This is the 30 now. That's a mistake. So then we'll get this current now here, I value. So that is V minus 12 by 20. V value how much now? 20 minus 12 by 20. So how much will come here? I is equal to 8 by 20. So this value 10s and this value 4. So we'll come it as 0.4 amperes now. Yes. Next one. In the given circuit, the value of I1 plus I3 plus I3 by I2 is. Now you can see I1 plus I3. Right, so this is a parallel combination. This voltage across this element, which will be equal 10 volts only. So then how much is I1 value? I1 is 1 ampere. I2 is also 1 ampere only. I2 also 1 ampere. Next, and we need to get this I3 value we need to get. Okay, so here at this location, here this voltage, how much now? This is positive, negative. This voltage is 10 volts now. And if we write the KVL in this loop now here, try for KVL in this loop. Now here, this is so 10 into I3 minus 20 plus 10 equal to 0. Then it is 10 I3 which is equal to 10. So that means I3 equal to what you tell me now? 1 ampere. So we need, they asking to find what tell me now? I1 plus I3 by I2. For this mod we need. So this will come to be I1 plus I3, that is 1 plus 1 by 1, which will be equal to 2 by 1. So that is 2 is answer. For the given circuit in steady state, VB minus VD is capacitor is they placed now. So in steady state, capacitor will behave like a open circuit. Now redraw the circuit now here. Yes, so they given A, this is B, C, and this is D. And this is 6 volts. Yes, here we have the resistance which is 2. And this one capacitor is a open circuit. This is also remote. This also remote. 1 ohm only will affect 2. And here this is 10 ohms. And this is 2 ohms. Yes, VB minus VD. Directly we can do. So similar to earlier only now. So this is VBD. And VB means this voltage. This voltage is VB. And this voltage is VD. Now tell me now VB minus VD. How much this value you can see at the B? How much this voltage now here? 1 by 3 into 6 minus 2 by 12 into 6, and which will be equal to 2 minus 1, and which is 1 volt. VB minus VD. So steady state, they are saying a steady state capacitor will behave like a open circuit. Next one. In the following circuit, the magnitude of current I1 only, no? Yes, I1 is, this is I1 here. So if we call this is a ground, right? So this voltage is 2 volts. And we need to write the nodal equation. We'll simplify it. We'll write the nodal equations only. It will become complex. So I can say this voltage is V1 and this voltage is V2. We'll get two equations will come. Yes, we need to solve the two equations. Right, so at V1 node, what we can say now? V1 minus 2 by 1 plus, so V1 plus 5 minus V2 by 1 plus V1 by 1 equal to 0. V1, 3V1. So that is 3V1 minus V2, and which is equal to minus 3. Okay. So second equation of V2 node. You can tell me now here V2 minus 2 by 2 plus V2 minus 5 minus V1 by 1 plus V2 minus 0 by 2 equal to 0. Now we can see now here that is minus V1 plus V2 by 2 V2 2V2 2V2, yeah, which is equal to 1 plus 5 6, that is minus V1 plus 2V2, which is equal to 6. Okay, next 3. So that is 3V1 minus, if I multiply with the 2, say, we'll get the V1 will simplify. So that is 6V1, okay, minus 2V2, which will come to be a minus 6. So this is, yeah, 5V1 equal to 0 now. V1 value will come to be a 0. V1 is 0. What are the V2 value? So V2 value, which will become as 3 plus 3. Now they are asking to find which current here, I1 or I2? Yes, might be. Check this thing here. Which current they are asking? Might be they are asking I2 maybe. Okay. So this I2 current. So if I want this I2 current, you can tell me now if they are asking this I2 value, that is V1 plus 5 minus V2 by 1. So this V1 value we got 0 plus 5 minus 3 by 1. So which will be equal to 2 amperes. Next, the given figure, the value of V0 is. The given figure, value of V0 is. Yes, this voltage V0. Yes, this voltage, common voltage V0. Let's write the nodal equations here also. So we can say now V0 minus 2 by 1K plus V0 minus 4 by 2K plus V0 minus 6 by 1K, which is equal to 0. So how many we have V0? 2 V0, that is 5 by 2 V0, and which will be equal to 2 plus 6. So that is 5 by 2 V0, which will be equal to 10. So that means how much will come the V0 value, which is equal to 4 volts now. So 5 twos and this V0 value 4. Next, in the figure shown, the current in the 10 volts battery is close to. Okay, they are asking to find this current, they are asking to find. This is I value. They are asking to find this current. Okay, what we can do? Nodal we can try? Yes. Better is nodal only. So then this ground, if I call this voltage is V, if I call, let's see this thing here. This voltage is V. Tell me the equations now here. V minus 20 by 7. Okay, V minus 20 by 7 plus V by 10 plus V minus 10 by 4 equal to 0. And simplify, get the relation. So V we have taken common. This is 1 by 7 plus 1 by 10 plus 1 by 4, and which is equal to what? Tell me now. 20 by 7 plus what? Tell me now here. 10 by 4 means 5 by 2. So we have taken LCM, which will be a 70 LCM. We multiply now. Simply 7 into, yes, now here 70 into 4 if we multiply. So then this value 40 here, and this value which is equal to 28 plus 70, and which will be equal to 14 is LCM now here. So this is 40 plus 35. So now I can cancel it now here. 14 fives. Yes, now here V value which will come to be a. So this is 111. So this is 138. 138 by 20, and which will be equal to 75. Now we can simplify V value. So this is 20 into 75 by 138 na. 2 tens, 2 6, and 280. So this is 750 by 750. 750 by 69. The current they ask him to find now. So this is I value how much now? Yeah, so 10 minus 750 by 69 by 4. So this value which will come to be a 690 minus 750 by 4 into 69. So this is 690 minus 750. 4 into 69. This is minus 0.217 amperes. That means current is flowing from where to where. You see this thing. We have taken this is positive to negative. Ulta is flowing now. So option C. We got negative now. So actually current will flows from like this. Minus now this direction current will flows. Okay. Yes, completed now. Tell me. Next one. The value of current I1 flowing from A to C is. They ask in a current from A to C. They ask. A to C. Now, first, what I can do here, that part of circuit, if we consider separately, and we'll find out the equivalent resistance first. Thereafter, we analyze it. Okay. Now, this part of the circuit, if you draw separately, so this part here, A, C, and this is B, and this is D. Yes, so here, okay, this is also 5. 5. This is also 5. Now this is 2. This is 2. And this is 2. And this is 2. And this A to C again, there is one more. So this 4, 4, I can simply say 8. Okay, here only they connected the battery, they connected. This is 8 ports. This connected, the source is connected like this. So this 8 volts. Okay. directly parallel. So this is 8 volts. So current is 1 ampere. Yes, so this current I1, which is equal to how much now? 1 ampere. प्रॉब्लम देखने के लिए बहुत डर लगेगा, बट लेकिन बहुत इजी है. Completed. Now see this thing here. An ideal cell of EMF 10 volts is connected in the circuit shown in the figure. Each resistance is 2 ohm. The potential difference across a capacitor is. So you can see now here. So the current flows. How the current will flows now here in this path mein jayega. These two resistors are series. And then, okay, so this is all are 2 ohm only. 2 to 4, 4 and 2. Yes, now 2 parallel to 4, which will come to be a what help me now 4 by 3. Capacitor is open circuit, right? And then which is will go via series now here. This is 2. So will come it as what help me now 4 plus 6. 4 plus 6 by 3. So which will be equal to 10 by 3. 10 by 3 is a resistance. So that means how much is I value? 10 by 10 by 3, which will become as 3 amperes. So this current is 3 amperes will go. Now tell me now here again, we need the here this voltage now. So that means current will divide. If I call this current is I1, tell me how much is I1 now here, which will be equal to 2 by 4 plus 2 into 3. Okay, so that means I1 3 and this is 2. So this is 2, 1 ampere. So this current is 1 ampere and this current is also 1 ampere. Now, so now here we can apply the KVL in this loop we can apply. If I call this voltage is V. Now what is this voltage V now here? 2 plus 2, which will be equal to 4 volts. Okay. Next one. For the circuit shown with R1 given, R2 given, okay, E1, E2, E3 given, the potential difference between the points C and D. E1 value they given 2 volts and E2 value given as 4 volts, E3 value given as 4 volts, R1 which will be equal to 1 and this is also R1. This is also 1 only, this is also 1 only, this is 2 here, this is 1 here. So we need this potential difference V if I write. We can write the nodal equations now here. V minus 2 by 1. No. Plus 1. 2 now here. This resistor. This is the ground. Plus V minus 4 by 2. Plus V minus 4 by 2 equal to 0. So how much will come here? 3V by 2. And which will be equal to 1 plus 2 plus 2. So this is 3V by 2, which is equal to 5. Then V is equal to what? 10 by 3 now, which means 3.33. Next, in the given circuit, the currents I1 is -3, I4 0.8, I5 0.4 are flowing as shown. The current I2, I3, I6 are KCL. I1 given minus, so that means this current, this direction flowing the I1 opposite direction, so this current is how much? 0.3. And I4 value, this current is 0.8. Next, I5 value, upward direction of this current is given as 0.4. Okay, now you can tell me now. So this current I6 is same only, that is 0.4. I6 is 0.4 only, this one. Okay, so then this is leaving, this is also leaving only. So that means I2 value, that is 1.1. 1.1. So this is I2 value 1.1. I6 is 0.4. Next, we need what? Tell me I3. So at this location, we write the KCL. I6 is entry current and I3 is also entry current. So this is next, and I2 is a leaving current, right? I2 is a leaving current and I1 is also entry current. I1, which is equal to 0.3, I6 value 0.4, and I3 value we should calculate, I2 value 1.1. So how much will come here? So this value 1.1 minus 0.7, so that is I3 value, which is equal to 0.4. So what's the option you can see now? Option B. Next, in the circuit shown, the potential difference between A and B is A and B. So what we can do now, first, we'll convert all these current source into voltage sources into current source will convert. Right. So then it will come to be a what? Tell me now here. Yes. Now this is A and this is 5 ohms. Here we have this resistance, which will be a 1, and this, I think so, parallel, will convert all into a voltage sources into current source. So then this current value, so this is the direction of current now. Right. Now again, so this is 1 ohm and this is 1 ampere. Now here, this is 1 ohm and this is 2 amperes. And this is 1 ohm and this is 3 amperes. So this is A and this is B. Now this is 5 and this is 10 here. 1, 2, 3. This will becomes what? Tell me now here, which will be a 6 amperes. These are in parallel. 1, 1, 1. So this value is 1 by 3. Again convert it to voltage source. That it will come to be a what? Tell me now here. Again we'll converting into voltage source. And this is resistance. And the positive, negative, and this here is a resistance. So this is 5. This is 1 by 3 ohm. This value 2 volts. And this is 10. This is point is B. So from this, what I can say now, A to B, how much is there now? 2 volts is there now? 2 volts. Okay, fine. Okay, yeah, that's it for today. And we'll meet in the next class. Okay, then, see you. Bye bye.